Hi everyone, welcome to Lecture 5, and in this lecture we will continue to discover some important discrete distribution. So far we have seen the uniform distribution, the Bernoulli distribution, binomial distribution, and geometric distribution. And in this lecture we will continue with negative binomial distribution. Let's say we have some independent trials, each having probability P of being a success, and we repeated these trials until we get our successes in total. So if we let x, which is the random variables, be the number of trials required to get our successes, x is said to have a negative binomial distribution. Okay? So the question is how we can compute the probability mass function of x, and x has a negative binomial distribution in this case. So the last kth trial, let's say we have repeated that trials k times, and the last one will be the success, right? That's for sure. And in the first k minus 1 trials, we should have exactly r minus 1 successes, right? I mean, let me write that one. So let's say we have some trials, and let's say each box corresponds to trials. And let's say r is equal to 3, okay? And how many trials I have here? 1, 2, 3, 4, 5, 6, 7, 8. So the k is 8. And let me change the color. Let's say the first trial is failure, second one is failure, the fourth one failure, fifth one failure, and sixth one failure. And the third one is success, and the 17th one is success. So until that point, until this one, we have got 2 successes, right? So what is the required number of successes is 3. So if that is success, I will stop at that point, right? So that's mean the last point, if the last point is success, and if I reach the required number of successes, I will stop the process. That's why the last one, the last trial should be success for sure. So if this is a success and the total number of my trials is k, that's means here I have k minus 1 trials, right? So how can I compute the probability of this trial, this particular trial? It is simply the probability of the product of probability of the failures. Like let's say this is q, the probability, this is q, 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 and q, and these are p, p, and p. So it will be simply one. I have 5 failures, q to the 5 times p to the 3, right? So what was the q, which is 1 minus p, and what is the 5? The 5 is actually the number of trials, the total number of trials minus the number of successes, right? So I can write it as k minus r, and times what is that is this p, and what is this 3, which is the number of successes, and it is r, right? So this is the probability of this trial. But here there is something more. This is not the only way I can get the R 3 successes, right? Maybe I will have something like that. 4, 5, 6, 7. And maybe I will get failure, 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 success, success, and success. So this is another way to get the 3 successes, right? So how many different way I can create to get 3 successes. So if the last one is success, that's mean I have to get R minus 1 successes in K minus 1 tries, right? So here in this part, I have to get 2 successes if this is the last one. So that's why I can create K minus 1 to choose R minus 1 different way to get 3 successes. So that's why this is the PMF of the negative binomial distribution. Okay, I hope that's clear. So, and we have to check if the PMF is valid, a proper one or not. So you can check the non-negativity and the range axioms. The what I mean by range, the probability should be between 0 and 1, and there are equalities. You have checked them easily, but let's check do all probabilities sum up to 1. So remember from the previous part, the total, the summation of the PMF should be 1, right? But before that one, I have to explain something to make things more clear in future. That is the expansion of the negative binomial series. So first, let me give you directly the formulation of this one, which is a 1 minus W to minus R, and this is equal to this one, okay? This one. So if that is the case, mean the summation of minus R choose I times 1, this is the first term of this one, to minus R minus I times the second term minus W to the I, the index. Okay, so this is the formulation of this one. This is the expansion of this one. So you can think this part as 1 plus minus W, or you can think A plus B in general form to the minus I. So, but let's do some trick here, and we will make things more simpler to use them in future, okay? The first one, what is this one? So far, we have seen the choose function like A choose B, and all these things was positives, right? But in this case, there is some negative number. But try to understand the logic, and the things will be much more easy. So let's say I have 10 choose 2. How can I calculate this one? It is the 10 factorial divided by 10 minus 2 factorial and the 2 factorial, right? And also there will be some cancellation. It will be 10 times 9 times 8 factorial divided by 8 factorial times 2 factorial. And these two guys will be cancel out each other, and I will end up with 10 times 9 2 factorial. So what's the meaning of that? What is the simple logic behind this calculation? That's mean actually start from 10, this number, okay, start from 10, and that is the 1, and go down, or in other words, reduce this number by 1, and by 1 2 times, this times, okay? So that's mean 1 and 2, I reduce it by 1, and I repeat this process 2 times. So this is the simple logic behind this calculation. So if this is the case, if this is the correct, and of course this is correct, I can do same thing for the negative number, right? Let's say this one. In this case, what is the logic? Start from this one and minus 10, reduce it by 1 2 times. So it will be minus 11, right? And 2 factorial. So this is exactly what I did here, okay? By using the inherent, the logic behind this calculation. So let's do the same strategy here. What's that mean? Which is actually minus r, reduce it by 1, and repeat this process I times. Okay? So what will be? Which will be the minus r times minus r minus 1 times minus r minus 2 until which one? Until the minus r minus I plus 1. Why? The first thing we will, before going to the details, the first let me say something. We will cancel this one because this is 1, and I can also write this one as minus 1 to the I times y to the w to the I. Okay. So if I open this one as minus r factorial divided by minus r minus I factorial times I factorial, right? So here I will get something, this one, and these two guys will cancel each other, right? So that means that will be go to somewhere, and before the cancellation, the term will be minus r minus I plus 1 times minus r minus I factorial, right? Because I will reduce it by 1, and this ones will be canceled to each other. So these two guys will cancel each other, and I will end it up with I factorial. So that's why this is the I factorial. Okay. So let's, here actually this one is something like that, right? For example, this one is minus 1 times r. So how many how many minus 1 here? E times, right? Why? Because I reduce it each term by 1 I times. I repeated this process I times. So that's why I can take this coefficient minus 1 to I, the outside of this division. So it will be common factor. And I will end it up with this one here in the numerator. Okay, so these two guys, the multiplication of these two guys will be 1, and I will have this term divided by I factorial times with the w to I. Okay, so what is this one? This is actually I plus r minus r, choose r minus 1, nothing else, right? Why? And in the, do you remember, we reduce it by 1 each time, right? So if I get this term to the end of this to the beginning of that multiplication, which is actually something like that, right? Minus 1 and times minus 2 until r times r plus 1. Okay, So that's why this is the r plus I plus r minus 1 and divided by I plus r minus 1, choose r minus 1. In other word, another way to write these things easily, like quickly, you can simply look at the last term or the beginning term. If we think inversely, it will be r plus I minus 1 eksi so in other words, or if you want to do this process quickly, you can just the first term, or if you think inverse of the last term here, because it from left to right, it is increased, but we were decreasing it. So that's why actually the first term should be this one, the first term minus this one. Okay. This will be cancelled to each other, and I can say that this will be this part. Okay, so I will end up with this one. So let me clear these ones. Let me clear everything here. So I can say that if I have a summation like that, okay, I can use simply this formulation. Okay, so this is important because we will use this this equality um, to calculating or to prove the sum of the PMF is 1, and also we will use that one to calculate the expected value of negative binomial distribution. So now let's check if the PMF, the sum of the PMF is 1. So this is our PMF, okay? So this is the PMF. And let's say here, let's say I is equal to K minus R. Why we did this one? Because the K in PMF, K is equal to R, but in our expansion, the index is starting from 0. So let's just do a simple trick, and let's say I is equal to K minus R, and we just change the index as I, right? And here, the small parenthesis, why K is equal to R? Because let's say the R is 3, okay? So that's mean I require 3 number of successes. So that's mean I have at least 3 trials, because if I'm lucky, I will get success, success, and success. So if the required number of success is 3, the number of tries cannot be 2, right? Because that's not possible to get 3 successes out of 2 tries. So that's why the minimum number of tries should be equal to number of successes. So we just put the so we just say that I is equal to K minus R, and that's mean the K is equal to R plus I. And instead of I, we just put instead of K, we just put R plus I, okay? Here. And also here. So I have something like that, right? So this is the constant term, so it can go outside summation here, and I will end up with this one. So what is that? This is actually this one, guys. This one. So I can use this formulation. I can say the 1 minus P is equal to W. So this will be what W to I. So and I can rewrite this part as 1 minus W, which is 1 minus P in our example. That will be 1 minus P to the minus R. And if you do some math operation, it will be 1 times. It will be equal to 1. Okay. So that's mean the PMF of the negative binomial distribution is a proper one because the sum of the PMF is equal to 1. So you can check the graph of some negative binomial distribution with some different parameters, different R's and different P's, the probabilities. So you can check it yourself, but let me say a small thing here. When you change the probabilities, for example, let's look at the first two distribution. The R is same, the number of successes is same, but we just change the probabilities. And the shape of the graphs, this is the first, this is the second one, and this is the first one, okay? The shape of the graph will be dramatically changed, right? But if you change the R instead of P, the probability, the new graph actually the scaled version of the previous one. Okay, so these two graphs similar to each other, but just like a scaled version of that one. So this is a one quick interpretation of or quick understanding how these parameters will change the shape of the negative binomial distribution. But if you want to check some other parameters, you can try it. Okay. So let's calculate the expected value. So what was the expected value? Which is the expected value is actually the x times PMF of x, right? So what is our x here, which is k, and what is the PMF? This guys, right? So here again, let's do something. First, change the index, okay? And let's say the k is equal to r plus I. And the new index will be I. It will be start from 0. And instead of k, I will use r plus I. Because this is the summation, okay, I expand this one. And I can rewrite if this is the A, I can rewrite this part as A times R plus A times I. Okay, so this is the same to what? Same with R plus I times A. So this is what actually did here. Okay. So this time, this guy's the R is a constant and it can go outside the summation, and R summation of R plus I minus 1, choose R minus 1 times P to R times 1 minus P to I. Okay. And also I multiplied same thing with I as I did here, and it will be summation of I times same guy. So what is this part? This is actually the PMF, right? Look here, this is our PMF, and we say that is equal to the 1, right? Oh, sorry, this guy is equal to this one. So we found that the sum of, so this is equal to 1. So I can just write 1 instead of this one, and it will be just R. So let's look at this guy, okay? Let me use this one. So the index value is 0. That's mean the first value is 0, right? Because I will start from 0. And if I multiply 0 with this guys, or no matter what I multiply with, I will get 0. So that's mean I can start with 1, right? Because if I start with 0, it will have no effect on the summation. So let's start from 1, and that will be the same guy. I didn't touch anything here, right? But something changed. So for example, r minus 1, what happened to this guy? That becomes I minus 1. And instead of I have R. So let's do that. How we change this term to this term. So let's start from this guy. Let me open a new page. What was that? Which is I times R plus I minus 1 divided by R minus 1, right? Okay. So before doing this one, if remember that the 5 choose 2 is equal to 5 to choose 2, right? So if the summation of these two guys is equal to this one, they will be equal. So let's open this guy first, which is R plus I minus 1. And what was the logic? I will reduce this term by 1 and R minus 1 times. I will repeat that reducing process R minus 1 times. So something like that. Okay. And let's say this part is R minus 1 factorial. So, okay, so okay, let's do that. How we change that term to another one. But first, remember that, or keep in mind, if 5 choose 3 will be equal to 5 choose 2, right? If these two guys, the summation of these two guys is equal to this one, they will be equal. So what was the term? E times R plus I minus 1 divided by R, choose R minus 1. So this is equal to this one, right? R I plus R minus 1. This is same, just I start with I. And I choose I, right? Because summation of these two guys is equal to this one. That's why these two terms are equal. So let's say if I open this one, what will be? This will be something like that, right? I times, I'm sorry, that's no parentheses. That will be I plus R minus 1 factorial divided by I plus R minus 1 minus I, the second term, factorial times I factorial. So this will be the R minus 1. And let's open this one until the R minus 1 factorial. So what will be is it will go somewhere R times R minus 1 factorial, right? And these two guys will cancel out each other. And if I open this one, I times I minus 1 factorial, these two i's will be canceled. Okay, so let's do another trick. What is the previous term? What is the term before the R? Remember that, which is R plus 1, okay? Keep that in mind. And let's take this guy here And let's write this one, r times I plus r minus 1 times r plus r minus 2 something something, and it will go r plus 1, and it will be divided by I minus 1 factorial. Okay. Okay, so how can I simplify this part? I can rewrite this one as something like that, right? R times I plus r minus 1, choose I minus 1 factorial. Sorry, I minus 1. Why? Because if I open this one, it will be I plus r minus 1 factorial divided by uh, I minus 1 factorial times r factorial, right? So if I open this one, I can make some cancellation, I will get this one. So that's why I can rewrite this part as this one. Okay. So that's why I can make just trick to write this part as this one. Okay, as this one, this one. So here, let's say which is let's say let's change the index again, and instead of using I, let's say we change the index as n, and n is simply I minus 1. Okay, here I just change index by using the n is equal to I minus 1. Okay, so instead of I minus 1, I just put n. Okay, so it will become, I just change this index, this I, this I, and this I, and this is the constant. I just send it to the outside of the summation, and I end up with r plus r times p to r summation, sum of r plus n, choose n times 1 minus p to n plus 1. This n plus 1 is coming from this I, because I is equal to n plus 1. And instead of I minus 1, we just put n. So let's continue. So this is the term we have now. And again, let's do some trick. Just take 1 minus p here and send it to the outside of summation. Okay, there's it here. And this part will be summation of r plus n, choose r times 1 minus p n. So this is similar to similar to this guy, right? So what was it? Which is similar to summation 1 I plus r minus 1 r minus 1 we I, and which is equal to 1 minus w to minus r. How? I can say the 1 minus p is w, and r is r minus 1 here. Okay, and so, and I can simply use this formulation. Well, there is a mistake here, it will be negative. Okay, please don't forget that one. This will be negative, this will be minus r minus 1. Why? Because the r here is equal to r minus 1 or corresponds to r minus 1, that's why this r is equal to r plus 1. Okay, and because I'm getting the minus of them, it will be minus r minus 1. Okay, now let me give you some quick piece of information about the negative binomial distribution and some relationship. We can think of a negative binomial variables as the sum of R IID, independent, identical, distributed geometric random variables. Okay, so we can think that variable, the negative binomial variable, as the sum of the geometric random variables. Why? So in the negative binomial variables, we aim to get some number of successes, right? And each trials can be think as the first success I have got, right? So that's why that will be sum of the negative binomial variables will be sum of the geometric random variables. So because each these trials can be thought as the geometric random variables. We can think as if we will get the first success. Okay, so the expected value of x, that's why is the sum of individual expected values of that geometric random variables, and the expected value of geometric random variables is 1 over p, so we can simply sum up all of them r times, because we aim to get r successes, and we will end up with r divided by p. So the last thing, because that xi is independent, that's mean the one will not be affected from the previous one, and that one will not affect the future one. Okay, each of them just independent trials, and because there exists independence, we can just sum the variance of that individual random variables, individual trials, to reach up or to calculate the variance of the negative binomial distribution. Okay, and we calculated the variance of the geometric distribution in the previous lecture, which was the q divided by p squared, and if we sum them r times, we will end up r times q divided by p squared. So this is the variance of the negative binomial distribution. So this is the end of negative binomial distribution, and we will continue with the hypergeometric distribution in next part. So thanks for watching.